All right, everybody, today what we're going to be working on, dadgummit, there we go, continuity at a point, dealing with graphical continuity. So let's take a look at this graph right here. There we go. I can slide it up and down. All right, so right now it says select all the correct statements about g at x equals -4, which is right here. All right, so it's asking at where x is a -4. So what we're going to do is I'm going to highlight this. All right, from the left, this graph is approaching a certain number, and from the right, it's also approaching a number. So here's what we're going to say. All right, we're going to say, hey, what is the limit? What is the limit of g of x? What is the limit of g of x as x is approaching -4 from the left? Just so you know, this means x approaches -4 from the left. So what is the limit of g of x? What is it approaching? Well, it looks like from the left, it's approaching the value of 1. All right, well, what's the limit of g of x approaching as x approaches -4 from the right? So a little plus sign means from the right. So this means x approaches, that's a horrible O, approaches -4 from the right. Well, as I'm coming from the right, it looks like it also approaches +1 right there. All right. So this graph definitely has a limit. All right, and its limit is at a 1 because it's both approaching from the left and from the right to the exact same number. Now it is not defined. So right here at x equals -4, it is not defined because it has removable discontinuity going on. All right, so let's take a look at our answers. So it does exist from the left and from the right. There is something that exists from the left and from the right. So I'm going to select that. There is a limit that does exist. Okay. All right. So does it, being that it exists from the left and it goes to the same number, I'm going to say yes, a limit exists as x is approaching -4, a limit exists. But it is not defined at x equals -4, and it is not continuous. In order for it to be continuous, this point right here would have to be filled in for it to be continuous. Right now there's a break in the graph, so it's not going to be considered continuous. Okay? So all I'm going to do is select just these two answers. All right, let's take a look at this next graph. Now, all right, let's take a look at this graph. So now it says select all the correct statements about g at x equals 3. So right at 3, right here, we see that it's actually going to two different points. So from the left, it's approaching 2, but from the right, it's actually approaching -2. So if I were to write this down as far as, here's what I would say, ready? The limit of g of x approaches 2 as x approaches 3 from the left. And then I would also say the limit of g of x approaches -2 as x is approaching 3 from the right. But actually at x equals 3, it is defined at -2. So g of x would equal -2. So g of 3 actually equals -2. So it is defined right there at that point. But you can see we have jump discontinuity happening here, so therefore it's not going to be continuous because it doesn't keep flowing like the other one. If this was a point right there, we would say that would be continuous. So this is still not considered to be continuous. So let's take a look at our answers now. All right. So is there a limit from the right and from the left? Yes, there is a limit. Does the limit actually exist? I'm going to say no, because it's going to two different points. But is it defined at x equals 3? I'm going to say yes, it is defined, and it's defined. It's at -2 at x equals 3. Is it continuous? No. All right. So in order for a limit to exist, it's got to go to the same point in order for that limit to exist. All right, let's do another one. All right, here we go. Oh, we got some jump discontinuity happening. All right, so around -1, it does exist from the left, and it does exist. There are two different limits. So from the left-hand side, it's going to 3. From the right-hand side, it's going to -5. So we are going to say that there is a limit from the left and from the right that exists, but there is no limit that does exist because it's going to two different points. And this time, it is not defined at x equals -1 because there is a hole there. Well, they're not a hole, but it's not defined because it's open circle, and it's not defined because it's an open circle. And it's definitely not continuous. So the only answer I'm going to choose is the first one. Okay? All right. So this is the last question that we're going to look at. So here it is defined, but right now it's going to this. It does exist as it's approaching from left and right. There is a limit that it does exist, which is right there. Okay? So I'm going to take a look at this one, and we're going to hopefully get this one right. It says select all the correct answers about x equals -5. And I'm going to say it does exist because it approaches to the same point from left and right. So I'm going to say a limit does exist. The limit actually is -3. But here's the weird thing. It actually is defined at x equals -5. It's defined to be at a 3. But it is definitely not continuous. The reason it's not continuous is because there's still a gap. There's still a hole in the graph. All right? So I think this is probably the one that would be kind of confusing to students because, like, wait a second. If it's defined here at basically at -5 is, here, I'll put it right here. If I say, what is g of -5, you would actually say g of -5 is at a 3. But if I said, from the left, what's the limit? And from the right, what's the limit? You would say the limit, I'll put it in blue, the limit of g of x approaches -3 as x approaches -5 from the left. And then we would say the limit of g of x approaches -3 as x approaches -5 from the right. But it's defined. This is the only point that it's defined at -5. It actually is defined at a 3. So that's where it kind of gets a little bit tricky. And I'll look at the answer choices so you can kind of see. So that's what you got to be careful of, okay? So there is a limit that it exists, but the limit is actually not at 3. The limit's at -3, all right? So I hope that was helpful. Hope you took some notes, and I hope you understand how to read this notation.